Good morning, I am Ashmita from Physical Science Department. Good morning, students. What is this? How do you say so it is a chalk piece? By seeing. Imagine it is a dark room. Will you be able to see what is in my hand? So what is needed to see an object? Okay, very good. Light. We need light to see an object and also to know about an object, right? Okay. In physics, what we call the study of light? Optics. Who said that? Jayashri, very good. It is optics. So optics is a study of light. So in order to know what is optics, we should know what is light. The definition for light is a light is an electromagnetic radiation that makes the object visible to our human eye. So it is an electromagnetic radiation. What is light? Electromagnetic radiation. An electromagnetic radiation is nothing but the form of energy that surrounds us everywhere from the radio waves we use to from the radio waves we use to hear news and also the heat waves, microwaves that eats our food. So electromagnetic radiation is generated when an electrically charged particle is moved through a medium or a space. So what is electromagnetic radiation? Anyone? It is a form of energy. Yes, very good. It is a form of energy. And next we will move on to the properties of light. Can anyone come? Full time. First property is light is a form of energy. So we saw that light is an electromagnetic radiation. And electromagnetic radiation is form of energy. Yes. So light is a form of energy. And the next is travels in a straight line. This means that a light always travels in a straight line. Consider a tube. When you see from one end, you will be able to see through other end. But when a tube is bent at the middle, you will not be able to see the other end. So this proves that light travels in a straight line. And the next one is no medium is needed. This means that a light does not need a particular medium to travel. It travels in all medium. For example, what are the mediums you know? Anyone? Air, water, any medium from this side? Can you see? No. Okay. So what is air medium then? Water. Yes, very good. First we have to know what is medium. A medium is a part, it's a substance that carries energy. What is a medium? That carries energy. Anyone? Stand up and say what is medium? Yeah. Say what is medium? It's very good, sir. Everyone clap for Priya. And the next property is C is equal to 3 into 10 power 8 meter per second. Here C is the speed of light in vacuum. What is C?
Speed of light.
Okay. The value is? I am specifying that it is in vacuum because the speed of light varies in different medium. Okay? And next is C is equal to nu into lambda. Here nu is the frequency and lambda is wavelength. A wave is generally characterized by a frequency and wavelength. Let me So here, the upper part is the crust, and this upper part is the crust. The distance between these two is wavelength. What is the distance between the two crusts? Wavelength. And this one complete wave till this, from this end to this end. This is one oscillation. And frequency is number of oscillations per second. So what is frequency? Individual answers. I need individual answers. Anyone? From this side? Anyone? Okay. Divavati, stand up. What is frequency? Yes, very good. Now, everyone clap for Divavati. What is the symbol for wavelength? Lambda. Yes. And what is the symbol for frequency? Mu. Okay, very good. And the next property is different lambda and different frequency. This means that among the visible light, each color light has different wavelength and different frequency. That means starting from violet, indigo, all the colors have unique wavelength and unique frequency. And the next one is among the visible light, violet has the lowest wavelength and red has the largest wavelength. This is why we use red in danger symbols. Now, why we use red in danger symbols? Highest wavelength. So we can see red from far distance. So we use red as danger symbol. And the next one is partly reflected and refracted. This is when a ray of light is incident in between the interface of two media, it partly reflects and partly refracts. Let us do an activity to witness a ray that is partly reflected and partly refracted. Okay? Shall we start?
Yes, ma'am.
Thank you. What is this? Beaker. I need a volunteer. Can anyone come from this side? No one is coming. Anyone? Yes, very good. Everyone clap for her. So she has a water bottle. She will pour water into it. Fill it to half of it. It's enough. See, she has poured water into the beaker. Now the upper, the upper part is the air medium and the lower part is the water medium. So we have two mediums here. Now, when I hit the light on the interface between two medium, it should partly reflect and it should partly, what it should? Reflect. Okay, shall we do that?
Yes, ma'am.
See, when the light is incident on the interface between the two medium, it refracts through the water, and from this point, it reflects. Can you see the bending of the beam here?
Yes, ma'am.
Since here it is very bright, you can't see the light exactly. Okay. This proves that when a ray is incident on the surface that is in between the two medium, it partly reflects and partly refracts. So is that clear? The properties of light?
Yes, ma'am.
Can anyone say any one property from this side and one property from this side? From this side, anyone? Vashi, stand. Tell anyone property.
Form of energy.
Yeah, it's very good. Everyone clap for her. Light is a form of energy. And this side, anyone? Yes, come from straight line. It's very good. It always travels in a straight line. Okay. Is the properties clear?
Yes, ma'am.
Okay. We know what is light and also the properties of light, right? Okay. Now tell me, when a light is incident on a surface, what are the possibilities that can happen? Next. Very good. Next. opaque medium and a shiny opaque medium, the light reflects. In a transparent medium, the light refracts. And in an opaque medium that is not shiny, the light absorbs. Okay? Now we will see the definition for refraction. Stand and read. What is the definition for refraction?
Light travels from one transparent medium into another, obviously the path of light undergoes deviation. This deviation of light is called refraction.
Let's consider. A refraction is nothing but when a ray of light is transfers from one medium to another obliquely, there is a deviation in its path. Let us understand this using a ray diagram. Consider this as a medium, refracting medium. The light is incident on it. Obliquely. Obliquely means slanting. It's very good, Nisha. When a light is incident on the refracting surface obliquely, what it should do? It should refract. So it refracts. The light perpendicular to the surface is considered as normal. The surface is considered as normal. So we denote normal light as N and this ray as incident ray and this ray as refracted ray. And the angle here, this is the angle with respect to the normal light is angle of incidence. And the angle with respect to this here is angle of refraction. Okay, is that clear? Here consider this medium as air and this medium as water. Are you able to understand this? What is this ray called? This ray is called incident ray. And this ray is
Refracted ray.
And what is this angle? Angle of incidence. Yes, very good. And this is
Angle of refraction.
and the line perpendicular to this is
Normal.
Yes. Is refraction clear?
Yes, ma'am.
Can we do an activity?
Yes, ma'am.
Lakshmi, come here. So we already have two mediums in this figure, right? What is the two medium? Okay, hold on. When I'm putting the pencil, what do you observe?
The pencil is sliding.
Bending. The pencil seems to be bent, right? Okay. Here consider the part of pencil in air medium as incident ray, and the part of pencil in the water medium as refracted ray. See, when a pencil is when I put the pencil slantly, that is in obliquely, it seems to be like it is bent. So this is due to refraction. Yes, and this picture shows what we did now. Okay, here the pencil looks like it is bent. This is due to refraction. And also, do you all saw stars? Have you seen stars?
Yes, ma'am.
Are you seeing the exact position of star?
No, ma'am.
So what happens there? See, when the star is in space, right? The medium in space is interstellar medium. We call the medium in space as interstellar medium. So the light from the star reaches Earth while passing through these mediums. So when there is a change in the medium, the light, what is the light doing? Refract. So the light refracts and we are not seeing the exact position of the star, but the apparent position we are seeing. Okay, is that clear?
Yes, ma'am.
And even in this picture, you can see there is a pond and the boy is looking at the fish, but he is not looking at the exact position of the fish. This is due to refraction. And what is refraction? Bending of light. Yes, very good. What happens here? The light travels from the fish to its height. First, it passes through water and then through air. So there is a bending of light happens here. This is refraction. So refraction is clear?
Yes, ma'am.
Can anyone say what is refraction? A definition? Can anyone? What is refraction?
Bending of light.
Yes, very good, sir. Everyone clap dispersion, let us see what is the refractive index. Okay, a refractive index is nothing but it's a dimensionless constant that determines how fast or how slow a light passes through that medium. So what is refraction? Refractive index. It determines
How far?
how fast or how slow the light passes through that medium. Let us see a proper definition for a refractive index. Next, stand up and read. Refractive index.
Diffractive index, the ratio of speed of light in vacuum to the speed of light in a medium is defined as refractive index mu of the medium. Mu is equal to
C by
C by V.
Okay. So it is the ratio of the speed of light in vacuum to the speed of light in a medium is defined as the refractive index mu of the medium. Here mu is a Greek letter that denotes the refractive index. Okay? And see what is C? We saw in properties, right? What is C? Speed of light in vacuum. And V is
Velocity.
yeah. Here she is very good. Say that in a particular medium. Yes, very good. So, everyone clap forward. So, this is the formula to find the refractive index of a medium. And these are some of the medium I have listed and this refractive index. Punita, stand up and read what is here?
Vacuum.
Vacuum. And the refractive index is
1.00.
1.00. Okay, next.
Air medium.
Air medium.
And the refractive index is 1.00.
1.00. Okay, sit down. And you stand and read. Stand up and read. What is the third one?
Water.
Water. And what is the refractive index?
1.33.
1.32. Next.
Ice.
Ice. And what is the refractive index?
1.31.
1.2. Next.
Glass.
Glass. And what?
Robot. 1.1.
1.5. Next one is
Diamond.
diamond. And what is the refractive index?
4.417.
2.
4.7.
Okay, sit down. As the refractive index increases, the speed of light to that medium decreases. And so from this we can say that the speed of light and the refractive index are inversely proportional. So you know what is inversely proportional, right? Opposite? No. Yes, very good. When one increases, the other decreases. So here, according to the refractive index, the speed of light to that medium changes. So tell me what is refractive index now? How fast or how slow it travels through a particle? It's very good. Everyone clap for it. Now we will see what is dispersion. When a composite light, she said that composite light is a mixture object. When a mixture of light passes through an optical medium that has non-parallel lines. For example, we have prism. Prism it is an optical medium. Optical medium is nothing but a medium that carries light. So this prism, when a light is passed through this prism, when a light is incident on this prism, it will disperse the white light into its constituent colors, that is 7 colors, starting from violet to red. What are the colors? Have you heard about Vijaya?
Yes, ma'am.
So can you say what are the colors in Vijaya? Anyone? From this side. Okay, from this side. Swati, start and say. What are the colors in Vijaya? Violet, indigo, blue, green, orange. Next.
Red.
It's very good, Swati. Everyone clap for Let's see the definition for dispersion. You understand? Read the definition for dispersion. When a beam of light
Half the composite light of the reference
or a composite light is
refracted
it's okay. Try.
transforms the medium
Transparent medium
result of the class
or water. It is into its
component
color.
colors.
This phenomena
This colored
dispersion of light. Yes, very good, sir. What is it is when a ray of white light is incident on a transparent medium. Here it is given transparent medium, but it can also be said as optical medium. When a ray of light is incident on a transparent medium, it is split into the component colors. We will not get the exact white beam here. It starts from violet, indigo, blue, green, yellow, orange, and red from the base of the order is from the base of the prism. Here, red has the largest wavelength and lowest frequency. Okay, and violet has the lowest wavelength and highest frequency. So the violet bends to a maximum and red bends only at the least. So let us visualize this through a model. This is not the exact prism, but I have just made to make you visualize the concept. Because we usually do dispersion in lab only, because we need dark space to do this light. See, when a white beam of light is incident on the prism, it disperses the white light into its 7 constant colors. What are the colors here? Vibgya. We can see say as Vibgya. So, are you able to witness the dispersion here?
Yes, ma'am.
Okay. What is this? Bubble. Do you see any colors in the bubble?
Yes, ma'am.
Why you see colors here? Dispersion. Because the light passes through this bubble and the white light is dispersed into its constituent colors. Okay? And the same happens here. Even in diamond, we can see dispersion because it is a non-parallel optical medium. So we can see dispersion in diamond also. And the next one is Newton's disk. We saw that white light is dispersed into the 7 constant colors through when it passes through a prism. So Newton decided to prove that when we mix these 7 colors, we'll be able to get the white light. So he made this disk. So this disk contains the 7 colors. If I'm rotating it, if it is rotated at high speed, you will see the exact white color. But here it will not be the exact, but you can see that the colors are mixing. Are you able to see that?
Yes, ma'am.
But you can't see the exact white because the speed is less here. Okay, what are the things we saw in today's class?
Refraction.
Refraction. First we saw refraction.
What is light?
What is light? And then
Properties of light.
properties of light, and then
Refraction.
refraction and
Refractive index.
next
Dispersion of
dispersion
light.
of light and Newton's disk. Okay? Priya, can you tell any 2 properties of light? Form of energy and then no medium is like that's why this. Okay, what is refraction? Can anyone tell? What is refraction? What is refraction? Bending of light. Yes, very good stuff. Well, coming tomorrow, try to find out the applications of refraction in daily life. Thank you.